So hello and welcome everyone. So I hope I'm live and audible to all of you. Please let me know if you're any. Okay. So I hope I'm audible to all of you. So please let me know. Alright. So welcome back to this particular channel of Pradhan Academy. Okay. So we were discussing on the JEE Mains previous year questions, and this today's session is again going to be on the same thing. We're also going to discuss about the JEE Mains previous year questions, but today our topic is going to be on the probability. All right. So I'm going to a live chat. Please give me a thumbs up if we are ready to start. I hope. All right. So this so far the things are covered is basically we have been started with discussing about the algebra, right? And if you look at the sessions that I have already taken up, so if you are new to this particular channel, I would first of all request all of you to please subscribe to the particular channel. And if you like the sessions, please don't forget to hit the like button. And also please share this particular session with your friends so that your friend can also take the benefit of these sessions. Okay. And these sessions are just are for free on the YouTube, right? And if you just try to practice these questions and you understand how to revise for or practice or revise along with your the JEE Mains preparation, you're basically going to be ready for your JEE Mains second attempt. Okay, so this session is going to be both a revision and as well as it is also going to help you to understand what are the different types of questions that you can expect in the actual examination. Okay, so if you just watch this particular session, you will basically easy to go with the sessions. Okay, so if you're new to this particular chapter of probability, first of all I would request all of you to please study the permutation and combination part, right? Please study the permutation and combinations. Okay, that is why I'm writing as P and C. Okay, so permutation and combination is really important in order to start with solving the questions of probability. Okay, so once you're done with that, I would recommend all of you to please study the NCERT book. Okay, because the NCERT, the both the class 11 and class 12 part, the probabilities are given really nice way. Okay, so once you're done with the NCERT solving, then your task is basically to discuss or study about the NCERT exemplar problem. Okay, so please try to solve the NCERT exemplar problem, and once you're done with all of this, then you're ready to go with discussing about the JEE Mains previous year questions. Okay, so today our topic is going to be on the probability part, right? And one more important thing that I would always say, that please make short notes. Please make short notes. Okay, if you are missing out on this part, then you are actually missing out on a lot of things, because these short notes which actually help you to revise the entire JEE syllabus just the day before the examination. Okay, because if you prepare the short notes and you have practice questions, then everything will be easy to recall and revise the concept as well, right? So please make sure that you're done with doing this. Okay, all right. So let's start with today's session on probability. Okay, so today our goal is basically to discuss about the concept of probability, and we will also see the JEE Mains previous year questions. We'll solve some MCQ and numerical type question. We'll also try to understand what are the types of questions that has been asked in the JEE Advanced in the integer type or the numerical type problems, right? We'll also discuss the paper pattern. Okay, so far the things are concerned. If you look at the pattern of the paper that is basically being asked every time, so mostly the pattern is something like this, that is you can expect at least 3 to 4 questions from the chapter of probability and statistics combined. Okay, so we are basically discussing the probability part today. We are basically starting with the probability part today, and the next class we'll discuss about statistics. We'll discuss about statistics in the next upcoming class, right? But if you look at this probability and statistics combined, you can at least see 3 to 4 questions. Okay, statistics there will be one question for sure. There will be one question for sure, and probability will be like 2 or 3 questions. So that combines 3 or 4 questions, right? So this is really an important session, and basically it will be help you to understand the paper pattern type. And once you understand or predict the paper pattern, you're basically good to go with the solving any types of question that can come up in your paper. All right, so with this, let us start our today's session on discussing the probability part, right? Please give me a thumbs up so that we can start with the session today. So I have a lot of questions taken up for today, but before we start on this particular session, I would request all of you to please watch the session that I have already conducted on permutation and combination, right? Please revise permutation and combination before you start this probability, right? Because in probability, what you will see that you are again going to count the number of favorable cases and divide it with the simple number of total cases that is possible, right? So that will give you the recurrent probability. All right, so starting with the very first problem over here. So the first problem is on your screen. Now I would request all of you to please try this problem. Okay, please try to solve this problem and tell me what is the answer you are getting. All right, so let us see what the question is talking about. So if we try to read the problem, so the question is talking about that we have been given with two bags. Okay, bag B1 and B2 are the two bags which are containing some balls, right? There are two sets of balls, that is one is four black balls and four white balls and five black balls, right? That is basically about the first bag, right? So once we start solving this problem, it is always advisable to draw the diagram in order to make it easy, right? So let us say this is basically the bag B1. This is basically the bag B1, which is consisting of the four white balls. So I'm denoting W as white and five black balls as B, right? And if I also have another bag, that is bag B2, which is consisting of n number of white balls, and three number of black balls, which is consisting of n number of white balls and three number of black balls, right? Now it is said that one particular ball is drawn randomly from the bag 1. One ball is drawn randomly from the first bag. One particular ball is drawn randomly from the first bag and is transferred to the bag 2, right? Now a ball is then drawn randomly from bag 2. If the probability that the ball that is drawn is white, that is given as, so if I draw the probability, so it is more of like a question of conditional probability, right? So it is saying that once you take one ball from bag B1 and then you take a ball from a bag B2, then the ball or the ball drawn or the white ball getting is basically given as 29 upon 45, right? Now before we proceed with the chapter, I will tell you some notations. That is basically for any event we try to take out the probability. So we basically denote the probability as P of E, right? That is probability of a given event E. That is basically given as number of favorable event for that E case divided by number of events in the total sample space, right? That is the simple definition of the probability, right? Now first of all, if you look at this operation over here, there is two operations which are taking place simultaneously, right? First of all, a ball is drawn randomly from bag B1 and is put into bag B2, right? So if I draw a ball randomly from bag B1 and I put it into bag B2, then there can be two possible choices, right? Either the first ball that is drawn from bag B1 may be white ball, or it may be also possible that I get a black ball, right? So there are two paths to it, right? Either I can draw a white ball, either I can draw a black ball. So if I draw a white ball, the probability of drawing a white ball is simply calculated as 4 upon 9, is simply given as 4 upon 9, because there are total four white balls. So I can select out of 4C1 divided by total ball is 9, so 9C1. So that is basically given me the result is 4 upon 9. Similarly, the probability of drawing a black ball from this bag B1 is basically given as 5 upon 9, right? These are the corresponding probability of the drawing a white ball or a black ball, right? Now if you draw a white ball and put it into this bag B2, then the number of white balls in this bag B2 will then become n plus 1 white ball and 3 number of black balls. And then if you try to draw a white ball from this bag with the given condition that you have drawn the white ball from the first bag, so that is basically given as conditional probability, that is probability of drawing white ball from bag 2 given that white ball is taken from bag 1. So W1 is a white ball from the black 1 and W2 is white ball from the black 2. That is basically simply given as n plus 1 divided by n plus 4. N plus 1 divided by n plus 4. Now similarly, I can also draw a black ball and put it over here. So if a black ball is drawn, then the probability of getting a white ball from bag 2 such that black ball is drawn from bag 1 is simply given as n by n plus 4. N by n plus 4, right? I hope you are following up, right? So if you see that there are two parts to it, right? Two parts to the probability over here. So therefore, the two parts to the probability over here. So therefore it is saying that you have to find a total probability of getting the white ball from bag 2. Now this case will be simply written by total probability theorem, by total probability, that is drawing a white ball from bag 2 is basically first of all getting a white ball from bag 1 multiplied with the getting a white ball from bag 2 such that white ball has occurred from bag 1 plus getting a black ball from bag 1 into probability of getting a white ball from bag 2 given that black ball has already occurred from bag 1, right? That is the total probability. So if you just try to calculate this part, it is going to give you the result as follows, right? Plus 5 into n divided by n plus 4 into 9, right? Which is going to be equal to 29 upon 45, right? Now I will just do the simplification over here. So it is going to be simply equal to 4 into n plus 1 plus 5 times of n divided by n times of n plus 4 is equal to 29 by 45. So if you just look over here, this 9 and 45 get cancelled out 5 times. So from this part I will get it as 9n plus 4 multiplied with 5 is equal to 29 multiplied with n plus 4. So that is going to give me, that is 45n plus over here it is going to be 20. So 45n plus 20 is equal to 29n plus, now 4 times 29 is basically equal to 126. I hope I'm correct, right? You can check it. So it is basically 36 3 carried over and 8 plus 3 is 11, so 116, right? So 116 is going to be the result over here. So therefore it is going to be 116. So from this part I'm going to get as 45 minus 29, which is basically equal to 16, so 16 times of n, so 16n is equal to 116 minus 20, and that is going to be equal to 96. So from there n is basically equal to 6. So I will have our value of n as equal to 6. So if you just look at the option over here, so that is you have to find out the unknown value of that n. So you will see that the unknown value of that n is going to be option number B, which is 6. That is clear from this particular problem. So n value is equal to 6, which is option number B as given in the problem, right? I hope this is clear to all of you. Please let me know if this is clear or not. Please let me know in the live chat if this is clear or not. I hope you are following up. Okay. And if you're into this particular channel, don't forget to hit the subscribe button. Okay. So you can always suggest to share these particular videos among your friends as well, so that your friends can also join this particular channel and we can start solving a lot of important questions. Okay, because there are a lot of things that are coming on up planned. Okay, especially for your JEE mains as well as JEE advanced. Okay, so because we have very few less time for your JEE mains preparation, especially more surprises are there for your JEE advanced. Okay, and also don't worry, we are going to come up with a mock test as well. Okay, so please make sure that you are subscribed to this particular channel and don't forget to hit the bell icon. Okay, so that don't miss out any upcoming notification on this particular platform. Okay, so stay tuned for the notification that are basically coming up, and don't forget to join the session live and solve the questions with me. Okay, please try to solve the question with me. You will get to understand a lot of things. Okay, once you solve the question, you will get a lot of things and you will understand, and that will actually help you to prepare or revise for your upcoming JEE mains second attempt. Okay, and even if you have any slightest question, you can always ask that question up, right? And if you like my teaching and you want to get personalized one-to-one doubt clearance or one-to-one classes, then you can definitely contact the number that is given in the description box. I hope you can follow that up. Okay, and don't forget to join the Telegram channel from the description box. Okay, so let's proceed with the next problem with this. So I hope this is clear to all of you. If it's not clear, you can definitely ask the question in the live chat, right? So let's move to the next question. So the next question is again a question where we basically are given with that 3 bags, right? So it is talking about that there are 3 bags. So bag one is consisting of 6 white balls and 4 blue balls. Okay, again B for blue, right? And similarly your bag 2 is consisting of 4 white balls and 6 blue balls, and similarly your bag 3 is consisting of 5 white balls and 5 blue balls, right? there is a composition of the individual bags, right? Now it is said that one of the bag is randomly selected. So if you just select one of the bag randomly, so one of the bag is randomly selected and a ball is drawn from it. If the ball is white, then what is the probability that the drawn ball is from bag B2? So it is the problem of the Bayes theorem, right? So I will discuss about the Bayes theorem quickly over here. Now Bayes theorem is one of the very interesting case of probability that you need to understand clearly, because Bayes theorem is the most important part of probability. Okay, so what is the Bayes theorem is talking about, right? So Bayes theorem is nothing but it is the inverse of the total probability theorem. Okay, so it is saying that if a particular event has occurred with the help of following paths, then what is the probability that if that event has already occurred, then what is the probability that it has occurred because of that particular path? That is what the inverse statement. Okay, you can also consider this as the inverse of total probability theorem, right? So if I try to draw it pictorially, so first of all, first and foremost thing to the Bayes theorem to hold true is that you must have n1, e1, e2 and up to so on up to n number of mutually exclusive and exhaustive events. Okay, first of all, you should have mutually exclusive as well as mutually exhaustive events that is consisting in the sample space, right? Now, once you have this all events are mutually exclusive and mutually exhaustive, then if you try to draw a pictorial diagram of it, so if this is the entire sample space, okay, if this is the entire sample space, let us say this is E1, this is E2, this is E3, right, and so on up to all the place up to En, right? That is En over here, right? So basically these are all the events that are the parts of this particular sample space, right? Now all of them are mutually exclusive and exhaustive, so therefore they have no intersection places, right? Now if I have an event A such that it is basically defined as event A which is having some intersection with E1, some intersection with E2, some intersection with E3, so that is event A is basically nothing but the summation of all the individual intersection of that particular event with the given events of the sample space, right? So event A is basically the individual intersection with the individual events and the given event, right? So that is the statement. That is whenever I ask you that what is the probability that a given event has occurred if there are three possible cases, right? That is the statement of total probability theorem. So this is basically the total probability theorem, right? So this is the total probability theorem, right? Now Bayes theorem is just the opposite of it. If it is said that this particular event has already occurred, if this is said that this particular event has already occurred, then what is the probability that this event has occurred because of any particular event E1 or E2 or E3 like that? Okay, so that is basically simply given as, so probability, so let us say so I have a probability of event A has already occurred, so I have to find out that what is the probability that a corresponding event that the event has already occurred and it is occurred because of this corresponding event, which is written as conditional probability of EI such that event A has already occurred. Probability of EI such that the probability A has already occurred, right? So that is simply given out as by the definition of the conditional probability. It is basically EI intersecting with A divided by probability of A, right? And probability of A is basically given by the total probability theorem, and this I can write by the properties that I can write it as simply as the occurrence of the event EI multiplied with the occurrence of the event A such that EI has already occurred divided by summation of all the events, right? Summation of all the events in the sample space, with the summation of event EI into probability of A given that EI has already occurred. That is what the total probability. So if you just divide this particular quantity by the total probability of that given event A, then this is a statement of the Bayes theorem, right? So let us try to solve this problem over here. So this problem says that if you have to draw the white ball, so if I draw a white ball from the bag 1, so the probability is basically going to be 6 upon 10. Similarly, the probability of drawing a white ball from bag 2 is given as 4 upon 10, and similarly from this bag it is given as 5 upon 10, right? And now each of the bags can be selected randomly from each other, right? So there is no such condition that a particular bag has to be selected, right? So therefore that probability of selecting bag 1 should be equal to probability of selecting bag 2 should be equal to probability of selecting bag 3, because there are no such problems that these particular bags will be given more weightage, right? So therefore these all bags can be selected as a equally spaced, right? So therefore this particular probability is given as 1 upon 3. This particular probability is given as 1 upon 3, right? Because I can select any one of the bag at a time, right? So it is not biased. So I am not biased towards any particular bag. Each of the bags has a equal weightage of getting selected, right? So now I have to basically find out the probability. I have to basically find out the probability, that is that if I'm having a white ball, then what is the probability that the white ball is drawn from bag B2? So what is the probability that the white ball is drawn from bag B2 is simply given as the probability of selecting bag B2 multiplied with multiplied with white ball such that bag B2 is already selected, divided by the total probability of getting the white ball, right? Total probability of getting the white ball, which is basically is equals to, so 1/3 multiplied with, so the probability of getting white ball from bag B2 is given as 4/10, right? And then divided by the total probability, that is 1/3 multiplied with, now I've taken the bracket, that is 6/10 from the first bag, 4/10 from the second bag, and 5/10 from the last bag. And if you just try to simplify this 1/3 get cancelled out. So ultimately the result you're going to get it as 4 divided by 15. 4 divided upon 15. That is going to be the recurrent probability, which is basically the option number B over here. I hope this question is clear to all of you. So we have the probability that the ball drawn is from the bag B2 such that it is a white ball is simply given as 4/15. Is simply given as 4/15. Right. So I hope this part is clear. I hope this part is clear. Please let me know if this is clear or not. Please let me know this is clear or not. If something is not clear, you can definitely question me. Okay. I hope we are on the same note. Okay. I hope we are on the same note. So if you have any confusions, so you can always question me. Okay. And if you're watching this session after the live is over, so you can always put that question in the comment section. Okay. I will be going through a comment section and will be love to answer your questions and query. Okay. And don't forget to join the Telegram channel to get the personalized doubt solving. Okay. Because if you want to get the solution, handwritten solution of it, you have to join the Telegram channel itself. Right. So that is clear to all of you. So I hope this is clear to all of you. I hope this is clear to all of you. So let's proceed with the next problem. So the next problem is basically talking about that S denotes the set of all the words that can be formed by the arranging the letters of the word garden, right? So I have been given a word garden, and by interchanging all the letters of the word garden, I am basically getting number of words, right? So S denotes that set of all the words that can be formed by using or interchanging the letters of the word garden, right? Now it is said that from that particular set S, one word is selected at random. One word is selected at random. What is the probability that the selected word will not have the vowels in the alphabetical order, right? So if you look at the given word over here, it's a question what we have solved in yesterday's class, right? We have discussed one question where the vowels are not in a together, right? That kind of problem is something kind of that, but not exactly, right? So you understand right over here that how important it is to understand the permutation and combination in order to get your questions of JEE mains for probability corrected. Okay, so therefore the given word is given as, so given word is garden, GARDEN, right? So if we look over here, the vowels are basically A and E, right? The vowels are A and E, right? So it is saying that the selected word will not have the vowels in the alphabetical order, right? So it may have the vowels like A and E, but it cannot have, so it cannot have the vowels in the alphabetical order. That is, it cannot have the any word which will have these two letters together. That is A, and after A there will be E, right? It can have EA, but it cannot have AE. This is not possible, right? So we have to count for the number of cases for which I'm having this scenario, right? So if we look at the set S, or if I just try to find the cardinality of the set S, that is the total number of words that can be possible, So this is basically given as total words possible from the letters of the word garden. So that is basically simply given out as, so we see that there are total 6 letters, so that is basically given as 6 factorial. That is the total number of words that can be formed, right? Now I cannot have the case when AE is always together, right? So that is basically I'm going to do a simple bundle method analysis over here. So that is, let us say, so words not having, or first of all let us say the words having A and E together, words having AE, AE together. So if I have AE together, but there is no internal arrangement is possible. No internal arrangement is possible. Okay. No internal arrangement. Because I know that A and E cannot be replaced with each other, right? I want to see the number of words having A and E together only, specifically A and E. A after that E, right? So no internal arrangement. Okay, so if they count the number of cases, then this is going to be basically, so I will treat this AE as a one particular quantity. I will treat this AE as a one particular identity, and then I will see over here. So I'm then therefore I will have 5 factorial ways, right? Because there are 5 identities together. Right, so there are 5 identities, and if I just try to arrange these 5 identities, that is going to be arranged in a 5 factorial ways. Right, now I won't multiply with 2 factorial because the internal arrangement is not allowed in this case. Right, so therefore the number of words not having A and E in alphabetical order is basically simply given out as 6 factorial minus 5 factorial, and that is the number of favorable events, right? Number of favorable events. So therefore, if we calculate the probability for the given event that I have to find it out, is basically given as 6 factorial minus 5 factorial divided by 6 factorial, and that is going to be my required answer for this particular problem. So that is going to be the required answer for the particular problem, that is 720 minus 120 divided upon 720 minus 120 divided upon 720, right? So from here you will see the solution is basically equal to, so that is going to be equal to 600 or 60 by 72, that is nothing but is equal to 5 upon 6, that is equal to 5 upon 6, right? So from this you will see that the option, so I hope I'm correct over here, right? So let me check if I'm not correct, right? So basically favorable cases are basically that cases that when my A and E, so not having the vowels in the alphabetical order. Okay, so it is talking about the selected word will not have the vowels in the alphabetical order. Okay, so let me recheck the calculation again. So when A and E are in order, so that cases, so the favorable cases can also be given out as, so from here you can also find the favorable cases as also given as, so there are total 6 letters, right? So out of the 6 letters you have to get the 2 letters that will be not having the arrangement, right? That is, this is also the way you can also get the favorable cases, right? Which is simply 62 into 4 factorial, right? The other 4 letters have no problem of getting arranged, right? Only the letters A and E had a problem, right? So you can also calculate the solution in this method as well. So let me recheck the calculation. Maybe something, an error is over there. Okay. So the thing is like, okay, so you can also try to solve this problem by this method, because you are basically having to calculate when A and E are in order, right? So if you try to see this case, is basically out of the 6 letters, right? There are 2 letters which do not have the internal arrangement, right? and the remaining 4 letters can be simply arranged in 4 factorial ways, right? So the probability from here will be simply given out as the favorable cases, that is 6c2 multiplied with 4 factorial divided by 6 factorial, and which is basically going to be equal to 1.2, right? You can always check that up. Okay, so the probability when A and E are in order, right? Now the probability, this is basically the probability when A and E are in order. So therefore the probability when A and E are not in order is simply given out by the complement of that particular thing, that is going to be over here, is equals to 1 minus 1 by 2, and that is also equal to 1 upon 2, right? So you will see that option number B is going to be the correct answer for this particular problem. I hope this is clear to all of you. Okay, firstly, see, when I was first time I was doing this particular part, is that I was thinking the case that I will find the number of words having this A and E together, right? But rather I can also solve it with a case that when I consider that A and E are in order, when I consider the case when A and E are in order, and then try to find out the probability that when A and E are in alphabetical order, the total number of cases, the probability is that given as half, right? So similarly, the probability when A and E are not in order, not in alphabetical order, then that is simply given as 1 minus that particular probability, the complement of it, right? That is also a way to solve for this question. So with this, you will have option B as the correct answer. I hope this is clear to all of you. Okay, so what is, so this problem is clear, and this is an interesting problem because you will try see that this problem is talking about the cases that you have studied that in the permutation and combination part, right? So let us move to the next problem. So next problem we have again a very interesting problem. It is talking that we are given with two numbers k1 and k2 which is chosen randomly from the set of natural numbers, right? And it is said that the probability value such that your iota to the power k1 plus iota to the power k2, the probability that the value iota to the power k1 plus iota to the power k2 is equals to is not equal to 0. Okay, so I have to find out that particular values or the probability that our k1 and k2 such that this particular value is not equal to 0, right? So if this particular value is not equal to 0, then I have actually four cases, right? That is, for each of the corresponding iota to the power k1, I have four cases, right? Four options, because I know that iota to the power anything will either be of the four choices, right? Either it will be 1, either it will be minus 1, either it will be iota, either it will be minus iota, right? These are the four cases that iota to the power anything can take up, right? So if you try to talk about the total number of cases, the total cases for k1 and k2 for which this solution that will be there, that is basically given as, so four solutions, four options for iota to the power k1 and four solutions for iota to the power k2. So that is basically total of 4 into 4, that is going to be 16 solutions, right? 16 possible cases, right? But I have to count the number of cases for which it is non-zero. That is, let us first of all count the unfavorable case. Okay, let us try to calculate the unfavorable cases. Let us try to calculate the unfavorable cases. Okay, so if I talk about the unfavorable cases, that is when I to the power k1 plus iota to the power k2 is equals to 0, that is the unfavorable cases. So let me tell you that iota is basically nothing but square root of minus of 1, right? Now if I have to count for the number of unfavorable cases, that is possible when I have this is 1 or this is minus 1 or this is minus 1, this is 1, right? Or similarly this is iota and this is minus of iota and this is minus of iota and this is iota, right? So if you just check over here, there are total of four choices. There are total of four case ways for which I will have these unfavorable cases, right? For which I will have this sum as 0, right? So therefore I want the favorable cases. So I want the favorable cases, that is when the sum is not equal to 0. So favorable cases for which, that is iota to the power k1 plus iota to the power k2 is not equal to 0, that is basically equal to 16 minus 4, right? So out of the total cases, you have to subtract the 4 cases, that is basically 12, right? So therefore, your recur probability when the sum is not equal to 0 is simply given as a 12 upon 16, that is equals to 3 upon 4. So that is simply given as 3 upon 4, which you can check from the option, that is option number A over here. So that is option number A over here, which is the correct answer to this particular problem. I hope this is clear to all of you. I hope this particular solution is clear to all of you. So please let me know if you have any questions or not. Please let me know if you have any questions. Okay, I may repeat it again if you have any questions. The thing is very simple. It is just about counting. Okay, once you understand how to count for the favorable cases and unfavorable cases, you're basically good to go with the questions. Okay, very simple, straightforward. Right, let's move to the next problem then. So again, we have an interesting problem over here. It is said that the three defective oranges are accidentally mixed with seven good oranges. Okay, sorry, the seven good ones. Okay, and on looking at them, it is not possible to differentiate between them. Two oranges are drawn at a random from the lot. If x denotes the number of defective oranges, then the variance of x is what? Right, now this is a question which is basically talking about the binomial distribution, right? So what is a binomial distribution? A binomial distribution is basically such an event which particular event has two following outcomes, right? There will be only two outcomes for a particular event, right? That is either, for example, if I toss a coin, I might either get a tail or I might get a head, right? So there are only two possible outcomes for a particular event, right? So therefore, if I toss a coin, I will either have a head or either have a tail. So that kinds of probability or that kind of distribution is basically called as a binomial distribution, right? So if you look over here, there are 10 oranges. There are 10 oranges, right? So in this 10 oranges, it is said that the three defective oranges. So there are three defective oranges, and there are seven good ones, right? So there are seven good ones. So there are total of 10 oranges, right? Now if I put them and mix them in a lot, and it is not possible to differentiate among them, so two oranges are drawn at a random from the lot, and x denotes the number of defective oranges, right? So x is the number of defective oranges. So xi denotes the number of defective oranges, and the corresponding probability pi is given as follows. So if the number of defective oranges is 0, so if the number of defective oranges is 0, so if I draw two oranges out of those 10 oranges and I have 0 number of defective oranges, that is only possible when I take only the good ones. So that is given as 7c2 divided by 10c2, right? Now then if I discuss that so this is basically called as the binomial variate, okay? So sorry, you can always call it as the distribution function. So if any discrete distribution function is over here, so you can call this particular over here, right? So this is the simple probability distribution over here, the probability distribution table, okay? And it is not a continuous case, it is a discrete case, okay? So this xi is equals to 1, that is one defective oranges, that is simply given as 7c1 into 3c1 divided by 10c2, right? So I'm also calculating the value over here, that is basically 42 upon 90. This value is basically again 42 upon 90. And if the number of defective oranges, that is xi, is equal to 2, then the probability is basically 3c2 divided by 10c2, right? So that is basically equal to 6 upon 90. That is basically equal to 6 upon 90, right? Now we have to basically calculate for this particular case, that is x denotes the number of defective oranges, right? Now I only draw two oranges, so therefore the number of defective oranges cannot be greater than 2 because I'm only drawing for two oranges, right? So we have to calculate the variance of this particular probability distribution. So for this particular probability distribution, now earlier I was talking about the binomial probability distribution. So this is not a question of binomial probability distribution, but you can always consider this as a kind of binomial probability distribution because there are two possible events, right? Either it will be defective oranges, either it will be good one, right? In that term I was talking about. But if you have the probability distribution function, which is also called the PDF, so once you have this PDF, then from this particular PDF you can always try to find the variance over here. So variance of this particular distribution x for the variate x is simply given out as expectation of x square minus expectation of x whole square. That is the definition of a variance. So expectation is basically nothing but the movement, right? So if I write expectation of x to the power n, it is basically a summation of x to the power n into the probability distribution of xi. So xi to the power n into probability distribution xn, and I is basically going from all the cases, okay? So I denotes all the cases, okay, for all i's. That is basically defined as the expectation over here, right? So from here you can always try to calculate the variance in the following way. So first of all, so this is nothing but the average, okay? So that is basically given as mu, or the mean, that is simply as xi into pi, that is summation of xi into pi, and you can do this, you will get it as 42 upon 90 plus 12 upon 90, that is equals to 54 upon 90, that is equal to 54 upon 90. And if you try to calculate this variance from there, it is basically equal to summation of pi xi square minus summation of pi xi whole square, right? So which is basically equal to, this particular term is going to be coming out as, so you can try to solve it, it is going to be 42 by 90 plus 24 by 90, right, minus 54 by 90 whole square, and that is equal to variance. So variance is sigma square, and sigma is basically a standard deviation, okay? So from this part you can calculate this variance over here, very simple, that is variance is equals to 28 upon 75. 28 upon 75, which is option number D, which is very obvious from here, right? So that is option number D over here. I hope this is clear. It's just by simply using the application of the formula, right? So once we know the distribution table, so once we know the probability distribution, we can simply calculate for the variance by using this following formula. I hope this is clear to all of you. Please let me know if you have any questions. I hope this is clear. I hope this part is clear to all of you, right? Okay, so shall we proceed with the next problem then? I hope this part of the solution is clear to all of you. So let us proceed with the next problem. Alright, so let's move to the next problem. So the next problem is talking about, now this is a really interesting problem, right? It is talking about there is a 2x2 matrix, okay, which entries can be either 0 or either 1, right? So it is a 2x2 matrix, so it's a square matrix of order 2 that is basically either 1 or 0, right? Now it is said that E be the event that A matrix is an invertible matrix, right? So a matrix is invertible only when the determinant is non-zero, right? So invertible matrix, for invertible matrix I must have the determinant should be non-zero, right? So the A is invertible if and only if the determinant of A should not be equal to 0, right? If and only if the determinant of A should not be equal to 0, right? Now I have this 2x2 matrix, so the determinant, so I can have the matrix something like 1 1 0 1. So in this case the determinant of A is not equal to 0. In this case the determinant of A is not equal to 0. So if I have the matrix like this way, so this kind of matrix this kind of possible matrix are by writing as 4 ways, right? There are 4 ways I can have this kind of matrix, right, for which the determinant is non-zero. Now you must be having a question, how the 4 cases are there, right? So it is very simple to understand the 4 cases. So what you can do, so there are 4 cases from this particular form, right? So you can take this case as, so you can interchange the 0. So 0 can be over here, 1 1, you can have 1 0 1 1, you can have 1 1 1 and 0, right? So these are all the 4 cases for which you have the determinant not equal to 0, right? Similarly you can have the matrix A as 1 1 and 0 0 like this, right? Where there are 2 zeros and 2 ones, right? So this also can be given by 2 ways, right? 0 1 and 1 0, right? These are the 2 ways in which this form can be given up, right? So there are 2 ways for this, okay? There are 2 ways for this and there are 4 ways for this. Okay, there are 4 ways for this and there are 2 ways for this, right? So therefore the number of favorable cases, therefore the given probability for which the matrix is invertible, or I can have the inverse of a matrix, is simply given out as the number of favorable cases is basically 6 divided by total number of cases. So therefore each of the elements can have 2 choices. Right? So there are total 4 elements, so each of the elements can have 2 choices. So total number of cases is going to be 4 into 2. That is the total cases. That is the total. That is going to be equal to 8, right? That is going to be equal to, sorry. So please let me check. Yeah. So there are 2 choices for these 4 events, right? And the thing is like that. So that is, let me see. So the thing is that, so there are 2 choices for these cases, and the total cases over there can also be given out as, so it is actually 4 into 4 actually over here, because the total number of cases will be basically simply be equal to 16. Okay, the total cases is going to be equal to 16. Okay, the total cases is going to be equal to 16, right? Because this is a 2x2 matrix and entries can be either 0 or 1, right? So the total number of matrices that is possible. So first and foremost is that what you can do, you can consider the matrix should be consisting of only zeros, right? So if the matrix is only consists of zeros, that is a null matrix, that is a first case. And if the matrix is only consisting of 1, then that is a second case, right? Similarly, if I consider only one is there and remaining all are zeros. So if there are only 1 and remaining all are zeros, so this type of matrix can be given as 4 ways, because this is four ways, right? Similarly, I have 2 ones and 2 zeros. This is given by 2 ways, right? This is given by this is given again by 4 ways. This is again by 4 ways, right? Similarly, if I have 3 ones and only 1 zero, then this is also given by 4 ways, right? This is also given by, so 4 plus 4 plus another 4 plus these 2 cases, right? And similarly, there is one cases that I am missing out. There are 2 more cases that can be also possible. That is basically when you have this 0 0 1 1, right? This case is also there, right? So that is going to make up all the total 16 cases, right? I hope this is clear to all of you. So therefore, the total probability over here is going to be 6 upon 16, which is basically equal to 3 upon 8, which is basically equal to 3 upon 8. And from here, you can see the option number A is going to be the correct answer for this particular problem. I hope this is clear to all of you. Right, this is going to be an interesting problem. These kinds of problems are basically simply solved out by doing cases, and once you do the cases, you are basically going to check the solutions for it. Right, now I basically want to give this particular problem as a homework problem, right? So I hope you understand the cases over here, how to build the cases and how to solve for the probability. So I want all of you to please try to solve this particular problem as a homework problem and let me know the answer in the comment section. Okay, so please let's solve this problem as a homework problem and let me know the answer in the comment section. Okay, and especially if you want to understand the part of probability that is more interesting, more easier, that is you can always practice those problems of binomial probability distribution. You can practice problems of the Bayes theorem, total probability theorem, conditional probability. Those are the most important part that is going to be coming up in your JEE mains part. So if you just focus specifically on that particular part, at least you can be sure that at least you will be able to solve the 1 or 2 questions of probability, or at least 1 question in the probability, right? So with this, I wish you all the best, and please make short notes and try to take help of these previous sessions or the discussion that I am doing it to understand or to solve your JEE mains previous year questions. So with this, let us end our session over here.